All right, welcome to Module 13, Solving Systems of Equations. Make sure your name is on here. And we are starting this today, May 17th. There are 3 lessons here. We're going to solve systems of equations in 3 different ways: graphing, substitution, and elimination. First, let's review some things to help us with this module. We're going to start with the pre-module review. Our objective for this lesson is that I can identify solutions. So let's review what solutions are. In math, a solution is the value that makes a statement true. So in the equation x plus 5 equals 9, 4 is a solution, because 4 plus 5 equals 9 is a true statement. So if we replace x with 4, it makes it true, which means that the solution for x is 4. 17 plus 5 equals 9 is not a true statement, so 17 is not a solution. If we replace x with 17, this is not true. 17 plus 5 is significantly larger than 9. So 17 is not a solution. Some equations only have one solution, and some equations have many solutions. So when we talk about solving systems of equations, we're solving for 1, 0, or many solutions between 2 equations. All right, let's talk about graphing solutions. Here we have an equation, y equals 2x minus 4. We're going to graph it. To do that, we're going to first plot the y-intercept. Highlighters are going to be helpful here. I'm going to go ahead and color code things. You'll want a blue and a yellow highlighter. I'm going to highlight our y-intercept in blue. Here's our y-intercept, minus 4. That means on our y-axis, our y is our vertical, we are crossing at negative 4. So I'm going to go down here to negative 4, and I'm going to put a dot. There's my y-intercept. That means that when x is 0, y is negative 4. 2 times 0 is 0. 0 minus 4 is negative 4. When x is 0, y is negative 4. So that's an important number. Next, we need to travel our slope. I'm going to highlight our slope in yellow. Our slope is this 2 right there. What that means is that we are going to travel over 2, or up 2, and over 1. Remember, we have our rise over our run for our slope. So up 2, over 1. So I'm going to start here. I'm going to go up 2, 1, 2, over 1, 1, boom. Here's my next point. And technically, I could go ahead and connect these, but I want to get some more points in there. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and notice it's a pattern. Oops, that one's a little wonky. Over here, if I'm going the other direction, I'm just going to go down to left 1 and keep going. And now I have my line. It is important that your dots are in the right place. I want you to be really precise with this. Don't put your dot like in the middle, because this is hard to tell where that is. Don't put it on a line in the middle, because that's hard to tell where it is. Put your dots exactly at the intersection.
Please excuse the interruption.
All right, we have our line. Next, we need to find the solutions to this equation. This should be an n. The n got cut off there. All of the solutions are any point on this line. For our purposes, we're just going to use a couple of these dots instead of these like midpoints, because that can be a little bit confusing. So remember, our x is the horizontal axis, so I'm going to go ahead and pick a couple points on there. I'm going to go ahead and pick 0, 2, 4, 6, and we'll call that good, because 8 is not on our table. We could put another number in there. I could go back and put in negative 2 if I want. That's fine. I should have put the negative 2 over here, but that's okay. All right, now, if our x values are 0, so here's 0, my y value is negative 4. If my x value is 2, here's 2. My y value is 0. We don't have to go up or down to get to the dot. If I go over to 4, I'm going to go up to positive 4 on our y-axis. If I go over to 6, I go all the way up to positive 8. If I go to negative 2, I'm going to go all the way down to negative 8. Here's what that means. These are solutions for x. Our x solutions are 0, 2, 4, 6, negative 2. It's really any x value we could make there. We just listed a couple here. Our y solutions are negative 4, 0, 4, 8, negative 8. There's more y solutions here, but these are just the ones we're including in our table. Each pair of numbers qualifies as a solution. When x is 0, y has to be negative 4. If x is 0 and y is 0, that's right here, that is not a solution to this equation because it's not on the line. So solutions are only things that make the equation true. All right, you're going to go ahead and jump into 13.1. Let me know if you have questions.